All right, so in this section of the notes, we're going to be learning all about solving equations. We're going to do that by using inverse operations. As a reminder, inverse operations are any operation that undoes another operation. For example, addition undoes subtraction and vice versa. Multiplication undoes division and vice versa. So what do we mean by solving an equation? Well, to solve an equation, you want to isolate the variable, or get the variable by itself is another way to think about that, by using an inverse operation. Sometimes we might have to use more than one. So let's take a look at some examples. Solve the following equations for x, round to the nearest tenth as necessary. All right, so let's take a look at this first one top left. So 3x equals 15. We've got 3 multiplied by x equals 15. Opposite of multiplying by 3 would be to divide each side by 3. And when we divide each side by 3, that leaves us with x by itself on the left side is equal to 5 on the right side. So 15 divided by 3 is 5. Feel free to use a calculator whenever you need to, guys. All right, next one. X divided by 5 equals 14. Opposite of dividing by 5 would be to multiply by 5. On the left side, that'll get you x by itself. For the right side, again, if you need a calculator, feel free to type this in. 14 multiplied by 5 is 70. And there's your answer for that particular problem. Okay, let's take a look at a couple more. So we've got x plus 10 equals 15. Opposite of adding by 10 on each side would be to subtract by 10. When you do that, you get x by itself is equal to 5. All right. Now the next one, 7x minus 10 equals 11. A little bit different because now it's not going to just take one operation. We're actually going to have to do 2 inverse operations to get x by itself. So how do you know which one to do first? Whichever number is not directly attached to the variable is the operation you'll undo first. So what I mean by that, if you look, 7 is directly attached to x. So we're going to have to wait before we can do anything with the 7. First, let's get rid of the minus 10. So let's go ahead and add 10 to each side. That gets us 7x on the left side is equal to 21 on the right side. Now we just have one more inverse operation to do. Opposite of multiplying by 7 would be to divide by 7 on each side. And we get x is equal to 21 divided by 7, which simplifies to just be the number 3. Let's take a look at a few more problems where we've got multiple operations to work through. So let's take a look at this next one. Negative 9 plus 2x is equal to 17. So again, the 2 is directly attached to x, so we can't do anything with it yet. Let's take care of the 9 first and add by 9 on each side. That gets us 2x on the left side equals 26 on the right side. Now we can get rid of the 2. Opposite of multiplying by 2 would be to divide by 2 on each side. And we get x is equal to 13. All right, let's look at the problem right below it. So negative 8 equals 17x plus 9. Again, the 17 is directly attached to x, so let's take care of the 9 first. And let's go ahead and subtract by 9 on each side. That gets us negative 17 on the left side equals 17x on the right side. Now to get x by itself, opposite of multiplying by 17 would be to divide each side by 17. So we get that negative 1 is equal to x. Which, if you wanted to, you could always rewrite and say x equals negative 1 so that x is on the left side, but you really don't have to unless you want to. All right, let's jump over to the other side here. Take a look at a few more. So we've got x divided by 9 minus 6 equals 1. So the divided by 9 is what's directly attached to x. So let's go ahead and get rid of the 6 first and add by 6 on each side. That gets us x over 9 is equal to 1 plus 6 is 7. Opposite of dividing by 9 now would be to multiply by 9 on each side. That gets us x by itself is equal to 63. Okay, let's look at the problem right below it. So we've got 0 is equal to 7x plus 32. So let's get rid of the 32 since that's not directly attached to x. So that gets us negative 32 on the left side equals 7x on the right side. So then opposite of multiplying by 7 would be to divide by 7 on each side. So that gets us negative 32 over 7 is equal to x. But it did say in the directions that it wanted us to round to the nearest tenth. So let's go ahead and figure out what that's going to be. I'm going to use these squiggled lines to say what it is approximately. So when you see these squiggled lines, what they mean is approximately. So not exactly, but pretty close to this number is what negative 32 over 7 would be. So if you type that into your calculator, negative 32 divided by 7, we get negative 4.5714 and some other numbers. Nearest tenth would be the first number to the right of the decimal place. Now it's 0.5, but because there's a 7 after it, remember we're going to round up. So that would be negative 4.6 rounded up. So negative 4.6 is going to be our answer. All right, I think we've got two more to look at here. So on the left side, negative 11x plus 17 is equal to 21. Again, let's get rid of whichever number is not directly attached to our variable. So let's go ahead and subtract 17 from each side. That gets us negative 11x is equal to 21 minus 17 is 4. Now to get x by itself, opposite of multiplying by negative 11 would be to divide by negative 11. And so we get x equals negative 4 over 11. Now again, we wanted to round to the nearest tenth. So let's go back to our calculator and type this one in. Negative 4 divided by 11. And we get negative 0.36 repeating. Again, we're rounding to the nearest tenth. So that's negative 0.3. But after the 3 was a 6. So once again, we're going to have to round up. Would be negative 0.4. All right, one more to go. We've got 10 is equal to 6x minus 50. So opposite of subtracting 50 would be to add it to each side of our equation. That gets us 60 is equal to 6x. And then opposite of multiplying by 6 would be to divide by 6. This time we don't really need the calculator. 60 divided by 6 is 10. And there's our answer. That's it for this video. In the next video, we will talk about how to solve equations where you may have to use the distributive property or might have to combine some like terms. In the meantime, have a great rest of your day.